In this video, I want to go over a couple of basic strategies for factoring polynomials. So we're going to go over a couple. The first one we're going to go over is when it's written in a form that's really nice and easy to factor. And the second is when it's not quite there yet, but you could write it in a way that's easy to factor. Okay, so let's go ahead and look at this first example. Here we have 3y squared times y to the fifth plus 2 times y to the fifth. So right away, what you're going to notice is that they both have y to the fifth in common here. So since they both have that term in common, you could think of y to the fifth, since it's in parentheses here. I'm sorry, not y to the fifth, y plus 5. Since they both have y plus 5 in common here, you could actually think of that as just one term, okay? Y plus 5 is in parentheses, so we're able to just pull that out as one term. So we can factor out a y plus 5 from each of these. And we're able to rewrite this as y plus 5 times 3y squared plus 2. So really, you can actually think of this as undoing a distribution. So to see y, let's see what happens when we distribute this y plus 5. Avoid the temptation to do the foiling here, but let's go ahead and distribute this y plus 5. If we distribute y plus 5 to this first term here, we'll have y plus 5 times 3y squared plus y plus 5 times 2, which is the same thing as we have over here, okay? So because of that, you could really think of this as just undoing a basic distribution, okay? So let's take a look here. Here we have 5w times w minus 3 minus w minus 3, okay? So once again, we see that we have a w minus 3 and a w minus 3 here. So let's go ahead and undo this distribution by pulling out w minus 3. So we'll have w minus 3 times 5w minus, well, to figure out what we're going to put here, you have to think what we're actually doing here. In a way, what we're doing is we're actually dividing out. We're actually, in a kind of a way, we're dividing out w minus 3 from each of these terms, okay? And then we're multiplying by w minus 3 over here, okay? So what that does is we're just rewriting it in a convenient way. If we divide out here and multiply here by this whole thing, we don't change the value of our overall expression. We just rewrite it, okay? So when we divide out by w minus 3, here we're going to have, in this one, we're going to have w minus 3 divided by w minus 3. That's going to give us 1. So we can rewrite this as w minus 3 times 5w minus 1. Okay? Now let's take a look at this one. Here we have 5y to the third minus 4y squared plus 10y minus 8. Okay. So we're gonna try to attempt to solve this problem by grouping. If you ever see something like this and you're told to factor it, this is probably the first thing you should look at doing, is see if you're able to factor it by grouping. So to do this, let's start by putting parentheses around these first two terms here, and then parentheses around these two terms here. Okay, so here we can sort of think of this as adding two separate expressions together. Here we have 5y to the third minus 4y squared plus 10y minus 8. So this first one here, let's go ahead and see what we can factor out. So if we want to factor something out here, what is our greatest common factor? Well, we have 5 and 4. 5, the greatest common, well, we have the factors of 5 are 1 and 5, and the factors of 4 are 1, 2, and 4. So our greatest common factor is going to be 1. So we don't really have to bother with pulling any numerical value out here, because that's going to end up allowing us to just multiply whatever our greatest common factor is by 1. But we do have y to the third and y squared. So because of that, we can pull out the smallest degree term here, which is going to be y squared. So this first one we can rewrite as y squared times 5y minus 4, okay? And again, that's because we're pulling out a y squared here. We're left with one y in this 5y to the third here. We pull out y squared, but we're left with 1y. So we have 5y minus 4. Okay, and we pulled out all of the y squareds from 4, so we're left with just 4. Okay, and let's see what we can pull out of 10y minus 8. Okay, so our factors of 10 are going to be 1, 2, 5, and 10. And then for 8, we're going to have 1, 2, 4, and 8. So our greatest common factor is going to be 2. So if we pull out a 2 here, that's going to give us 5y minus 4. And look at that. If we're able to do this, we see that we have 5y minus 4 in each of these. So we have a common term. And now we can go ahead and factor out or undo our distribution of 5y minus 4. And if we do that, we're going to have 5y minus 4 times y squared plus 2. Okay? And again, if you want to see this go the other direction, we can distribute 5y minus 4 to each of these. And that's going to give us y squared times 5y minus 4 plus 2 times 5y minus 4. And you see we get back what we had here. Okay? So our final answer is actually going to be this right here. It is 5y minus 4 times y squared plus 2. Okay, let's go ahead and see one more example here. Here we have 3y to the third minus 4y squared plus 9y minus 12. Okay, so here we can go ahead and see if we can factor something out of these first two, and then separately these second two. So here we have 3 and 4 for our numerical terms. So the greatest common factor between those two is going to be 1, okay? Because 3 is 1 and 3, and 4 is 1, 2, and 4. So we're going to have 1 as our greatest common factor. And we have y to the third y squared. So once again, we can actually pull out a y squared, and we're going to be left with 3y minus 4. Okay, and then here we can factor on the second term here, second part of this expression, we can factor out a 3, because our factors of 9 are 1, 3, and 9, and our factors of 12 are 1, 2, 3, 4, 6, and 12. So our greatest common factor is going to be 3. And if we divide each of these terms by 3, we'll have 9y divided by 3, which is going to give us 3y, minus 12 divided by 3, which is going to give us 4. So look at that. Here we have 3y minus 4 and 3y minus 4. So we're able to factor that term out and undo the distribution, which is going to give us y squared plus 3 times 3y minus 4. Okay, last one here. Here we have 2w plus 6, 2w to the 6th plus 7w to the 5th minus 6w minus 21. Okay, so we might have to get a little more creative with this one, and we'll see why here in just a minute. But for now, let's focus on these terms here. And what we're actually going to do, for the sake of making this, it's making this easier. It's always good if we have a plus sign in the middle here. So if we could somehow insert a plus sign, that would be good. And we actually can do that. We can rewrite this. We can rewrite this as 2w to the 6th plus 7w to the 5th plus negative 6w minus 21. And you'll see why this is going to be advantageous for us here in just a minute. Okay, but it's usually good if you can write it with a plus sign here. Okay, so here we have 2w to the 6th plus 7w to the 5th. Well, 2 and 7 are both prime numbers, meaning they're only divisible by 1 and themselves. 2 is divisible by 1 and 2. Its factors are 1 and 2, and 7 has factors of 1 and 7. So we can't pull either of those out. But we have w to the 6th and w to the 5th, so we can rewrite this as w to the 5th times 2w plus 7. Okay, so now we want to see if we're able to factor something out of negative 6w minus 21 so that we can get 2w plus 7, okay? So let's see if we can do that. Well, our greatest common factor here, between, at least on the numerical side, here we have 6. This is going to give us 1, 2, 3, and 6. And then we're going to have for 21, we're going to have 1, 3, 7, and 21. Okay, but think if we were able to pull out a negative 3 here, because that would be our greatest common factor. If we were to pull out a negative 3, okay, let's try that. We will be able to, if we're dividing out a negative 3, we are going to end up with positive 2w and then positive 7. So we get 2w plus 7 and 2w plus 7. So then we can undo our distribution here, and we end up with w to the 5th minus 3 times 2w plus 7. Okay, so my best advice with these is just to go on Alex and practice these as much as possible. Sometimes it's just learning how to rewrite these, learning the patterns to pick up on here. And as always, if you have any questions about this one, because I do find this going to be a slightly harder topic, please let me know, and I'd be happy to assist you in any way I can.